If everything you know about planets comes from our solar system, prepare to forget it. Because in the last few years, NASA and the James Webb Space Telescope have uncovered worlds so bizarre, so extreme, and so contradictory to the rules we thought were unbreakable, that scientists are now questioning whether our idea of a normal planet was ever correct. This story doesn't start with familiar Earth-like worlds. It starts with planets that break physics, planets that should be destroyed but aren't, worlds that orbit so close to their stars they complete a full year in less than a day. Others are so far away and so cold they should be silent and dead, yet show signs of unexpected energy. And then there are the real mysteries, planets that appear almost perfect for life, but hide dangerous secrets scientists only recently uncovered. For decades, we thought life could exist only in narrow Earth-like conditions. A certain distance from a star, a certain temperature, a certain atmospheric balance. But the deeper we look into the galaxy, the more we realize how small and simple that assumption was. Among thousands of exoplanets, patterns have started to emerge. Patterns that hint life might not just be possible elsewhere, but might thrive in environments we once called impossible. A world with oceans deeper than Earth's entire crust. A world locked with one side an eternal day and the other an endless night. A world made almost entirely of iron. A world with winds so powerful they stripped the surface down to its core. And yet somehow, some of these planets remain surprisingly stable, surprisingly balanced, surprisingly alive. This is the new problem scientists face. Each discovery raises more questions than answers. Why do some planets resist destruction despite impossible heat? Why do others remain warm despite receiving almost no energy from their stars? How is it that Earth, once considered a model of habitability, now seems like just one example among many? And beneath all of this lies the biggest question we've avoided for decades. If these planets truly exist, and if they break every rule we know, what else might be possible out there? What did we miss? What are we not seeing? And are we ready for the truth scientists are slowly uncovering?
Let's begin with the planets that shouldn't exist at all, the ultra-hot giants. These are massive worlds orbiting so close to their parent stars the temperatures should evaporate their atmospheres in a matter of years. They orbit faster than any logical orbital mechanics should allow. Some of them skim the surface of their star so closely that a single solar flare could tear them apart. And yet, they survive. Why? NASA now believes that some ultra-hot planets may have magnetic fields so powerful they can repel a star's radiation. Others may constantly regenerate their atmospheres through violent volcanic cycles. Webb has recently observed metal vapors, iron, titanium, even quartz, circulating through these atmospheres like storms made of molten rock. But not all exoplanets are hostile. In fact, some seem almost too perfect. Consider worlds like Kepler-22b or LHS 1140b, super-Earths that are larger, heavier, and more stable than ours. Gravity stronger, weather calmer, oceans deeper. These planets may maintain thick atmospheres for billions of years, offering steady conditions ideal for complex life. But perfection can be misleading. A thick atmosphere might hide lethal greenhouse effects. A deep ocean might prevent land masses from ever forming, making evolution extremely limited. And then there are tidal-locked planets, worlds with one side always facing their star. Scientists once believed they were uninhabitable, one side burning, the other freezing. But new models show the Terminator zone, the thin ring dividing day and night, could offer mild temperatures, soft winds, and permanent twilight, a stable, gentle environment where life might flourish. Then the real bombshell arrived. evidence suggesting some planets may have atmospheres that existed before their stars even fully formed. That would mean life could start earlier than expected, giving it a massive head start compared to Earth. Meanwhile, strange chemical signatures, methane, dimethyl sulfide, suspiciously balanced oxygen ratios have appeared in the atmospheres of a handful of distant worlds. These could be produced by geology or by biology. No one can confirm either possibility yet, but the debate inside the scientific community is more intense now than ever before. Exoplanets aren't just strange. They're forcing us to rewrite the timeline of life, the rules of habitability, and our understanding of how common living worlds might actually be.
But the biggest discoveries aren't about exotic giants or ocean worlds. They're about planets that mimic Earth so closely it's genuinely unsettling. Take planets like Kepler 452b or TOI 700d. They sit in the habitable zone, they have rocky surfaces, and they may have liquid water. But their stars behave nothing like our Sun. Some are unstable. Some emit bursts of radiation millions of times stronger than anything we experience on Earth. And some are so quiet, so perfectly stable, that astronomers question whether we truly understand their internal cycles. If a star is too violent, life is almost impossible. If a star is too quiet, life might develop in ways we cannot predict. What's worse, many Earth-like exoplanets orbit red dwarfs, stars that live trillions of years but bombard their planets with charged particles. For life to survive there, a planet needs an extremely strong magnetic field. Earth's magnetic shield is the result of a molten iron core still cooling from its violent birth. But super-Earths might have cores heated by tidal forces, creating magnetic fields far stronger than Earth's. In theory, such worlds could be safer than ours. Meanwhile, Webb's new atmospheric analysis techniques have uncovered unexpected atmospheric fingerprints, thick cloud decks, unusual light scattering, hints of moisture, and temperature gradients that resemble Earth's climate zones. But perhaps the most mysterious discovery is this: some planets appear hotter than they should be. Not by a small amount, but by margins so large they imply hidden internal heat sources. Possibilities include tidal heating from nearby planets, radioactive decay in unusually high concentrations, or something entirely new, something we don't yet understand. And then there's the strange issue of missing planets. In several star systems, gaps appear where planets should logically exist. These empty lanes might be caused by gravitational disruption, planetary collisions, or possibly worlds so dark and cold that they're nearly invisible. Some scientists believe rogue planets, worlds drifting without stars, might pass through systems and steal planets from their orbits, or, in rarer cases, they might deposit new planets entirely. This opens the door to a cosmic possibility that some habitable worlds might not have formed with their stars, but arrived later, bringing chemical histories unlike anything else in the system. If true, life in the universe could be far older and more widespread than we dared imagine.
So, what does all of this mean for us? The truth is both exciting and unsettling. For decades, the search for habitable worlds was simple: find planets like Earth. Now we know that habitability might depend on factors we never considered: planetary mass, atmospheric chemistry, magnetic fields, tidal forces, internal heating, and even the history of the star system. And Webb is still just getting started. Upcoming missions like the Habitable Worlds Observatory and ESA's Ariel will directly scan exoplanet atmospheres for biosignatures. We may soon detect not just water vapor, but complex organic chemistry, perhaps even the unmistakable chemical imbalance produced only by life. But even if we find a perfect Earth twin, living there would not be easy. Gravity could be too strong, pressure too high, days too long, weather too extreme, And travel, well, interstellar distances remain our greatest obstacle. The nearest potentially habitable world is over 4 light-years away. With our fastest spacecraft, it would take tens of thousands of years to get there. Yet, humanity has always solved impossible problems. Nuclear propulsion, fusion drive concepts, light sails powered by lasers, antimatter engines. These ideas sound futuristic today, but so did flight, electricity, and computers in their time. And if we ever reach an exoplanet, the first humans may not step onto the surface at all. They might live in orbital habitats, shielded from radiation, using the planet below as a source of water, minerals, and energy. But here is the hidden truth, the one scientists now whisper more openly. Earth may not be the template for life. It may be the exception. The universe is full of planets stranger and more diverse than we ever imagined, some terrifying, some promising, some unimaginably beautiful. And somewhere out there, among billions of worlds, there may be planets where life has begun, evolved, and thrived long before Earth was even born. The question is no longer whether such worlds exist. The question is how soon we'll find them and whether we'll be ready for what we discover.